Hello students, welcome to IMS Gate Academy. Students, am I audible? Can you see the screen? Please comment in the chat box. Am I audible students? Please comment in the chat box. I'm just waiting for the answers from you. Am I audible? Okay. Good evening everyone. I hope you are doing great with the GATE preparation. Students, let me tell you one important thing. As we are inching towards the GATE exam, everyone has a desire to secure a better rank in GATE exam. So, as part of the GATE score booster, we are trying, it is like a capsule for the students who are aware of the concepts and all. If they want to go through the most conceptual problems, then it is the right place for you. So, students, it's my sincere advice. Good evening, Sai. Everyone to follow this class very sincerely. The second important thing is, whatever the classroom which I am going to cover, I will be sharing the classroom notes in the Telegram group mentioned in the link. So students, whoever is interested to look into the classroom notes and to have a detail of the all the conceptual problems, then you can join this Telegram group. Apart from this, students, I am proudly say that IMS Gate Academy is conducting the offline and online GATE coaching at, good evening Shabir, we are conducting the online GATE coaching and also offline GATE coaching. And remember students, at offline classes, we are offering at Bangalore and also at Vijayawada Bench Circle. We cover 800 plus hours of GATE coaching, my dear students. Especially civil engineering, we have around 13 subjects which comes under GATE component. And in addition to this, everywhere practice makes man perfect. So you should have the thorough material. For this thorough material, for every subject wise we have a conceptual book. Apart from this, we have the exercise book where you can practice the questions from level 1 to level 2 to level 3. And remember my dear students, the key success for IMS GATE Academy is the one-to-one mentorship and also the doubt solving portal. These are the two important things which made the student success in the IMS GATE Academy platform. And remember my dear students, and the last one is the test series. If you have already prepared for the GATE exam, if you want to test yourself, we have the complete test series which we call All India Mock Test Series. In the test series, we include chapter test, subject test, multiple subject test, and also the most important All India mock test, which looks like the same GATE platform when you are writing the real-time exam. So students, with this we are done with the intro part. Now let us quickly enter into the subject. Myself Sandeep Adari, lead mentor at IMS GATE Academy, trained 20,000 plus students with 10 plus years of experience. Students, in the previous session, you have enjoyed the session on soil mechanics. Good evening, Bhuvan. Now let us start the important topic called foundation engineering. So today I am here to explain you the concepts related to foundation engineering. Okay. Now when I come to foundation engineering, my dear students, see, whatever the load which is falling on the slab, it has to transfer to the beam and to the column and then to the footing, and the foundation rests on the soil. So a foundation is a key component in the construction process. And coming to the soil geotechnical engineering, the second part after soil mechanics is foundation engineering. In foundation engineering, mainly we have the stability of slopes, which is a very important concept. Stability of slopes. Next one we have is the earth pressure. Shallow and deep foundation. Shallow and deep foundation. And the final one we have is the soil exploration. So students, these are the topics related to the foundation engineering where you should require extra attention. Almost we are going to cover 6 marks in the GATE exam from these concepts. So let us start the first topic, slope stability. Now let us start the first topic, that is what, sir? Slope stability. So here see students, when I talk about slope stability, see students, why do you want to study about slope stability? Suppose if you are seen in the places like ghat roads, there will be a lot of landslides happening. To protect the landslides, we come across retaining walls. So what is the reason for the landslides? The slope is unstable. So due to that slope unstable, because of the unstable of the slope, we are constructing a retaining wall. The retaining wall again works on the principle of the earth pressure. Means retaining walls are designed according to the earth pressure. So here when I talk about slope stability, what could be the reasons for the slope failures? It can be earthquake force or seepage force or uplift force. One more important thing, students, I am going to give you the idea only, but I will give more importance to the problem solving, okay, in this session. And in slope stability of slopes, we have two types of slope, students. One is the finite slope. In stability of slopes, we have two slopes. One is the finite slope, and next one we have is the infinite slope. So to avoid the slope failure, we should calculate the factor of safety. So my dear students, when you talk about finite slope, when the slope length is limited, we call it as finite slope. When the slope length is unlimited, then it is called infinite slope. Usually see students, in infinite slope, you will be observing translational failure. Usually in infinite slopes, you will be observing translational failure. And remember, in finite slopes, you will be observing rotational failure. What are the two types of failures we have? Rotational failure, and other one we have is the translational failure. Agree, my dear students? So let me start with the translational failure. Now, the factor of safety for translational failure. And remember, students, translational failure is observed in which type of soils? In which type of slopes? It is observed in infinite slopes, sir. Translational failure observed in infinite slope. If suppose this is a slope, the translational failure occurs at some depth parallel to the slope, okay? And usually translational failure is observed in infinite slopes. So the factor of safety for translational failure is given by the formula shear strength upon, it is given by the formula, the factor of safety for translational failure is given by the formula shear strength upon shear stress, okay? The factor of safety for translational failure is given by the formula shear strength upon shear stress. Next, here if you see, for C5 soil, for a soil which has both cohesion and angle of internal friction or angle of repose phi, for C5 soil, this formula is very, very important. Factor of safety for translational failure is given by the formula C plus gamma z cos square I tan phi upon gamma z cos I sin I. So see students, the factor of safety for C5 soil, you have C plus gamma z cos square I tan phi upon gamma z cos I sin I. Immediately you will ask me, what is I? See students, if I consider I is nothing but the angle of infinite slope. What is I, sir? I is nothing but the angle of infinite slope. Am I clear? So see students, translational failure is observed in infinite slopes. The factor of safety for translational failure is defined as, it is the ratio of shear strength upon shear stress. And you have the equation for C5 soil, C plus gamma z cos square I tan phi upon gamma z cos I sin I, where I indicates the angle of infinite slope. Agree, students? Now, here if they tell you for cohesionless soils, see students, this is important. For cohesionless soils, what are cohesionless soils, students? For your information, the cohesionless soils are nothing but sand and gravel. Cohesionless soils are what, sir? Cohesionless soils are nothing but sand and gravel. In cohesionless soils, C will be 0. And remember, my dear students, in case of C-pace, this is a very, very important formula. We have seen 2-3 times gate question on this formula, my dear students. In case of C-pace and also for cohesionless soils, in case of C-pace and cohesionless soils, the factor of safety, okay, for cohesionless soils, the factor of safety is given by the formula. Can anyone let me know? It is given by the formula gamma dash by gamma sat into tan phi upon tan I. Okay, the factor of safety for what, sir? The factor of safety in case of C-pace and for cohesionless soils. What is the factor of safety? It is given by the formula gamma dash upon gamma sat into tan phi upon tan I. Here remember again, students, gamma dash is nothing but the submerged unit weight, where you can write submerged unit weight gamma dash is equal to gamma sat minus gamma W. Okay, here I is nothing but the angle of infinite slope. So remember, students, with this formula we have seen 2-3 times in the gate question. This is a very important formula. And also see, students, the factor of safety for C5 soils also is important. Okay. Now see, students, next we have is rotational failure. What, sir? One is translational failure and rotational failure. Remember, see, students, rotational failure is observed in a curved surface. See, usually rotational failure occurs along a curved surface. Okay, here usually rotational failure occurs in which surface? On a curved surface. Here the factor of safety for rotational failure is given by the formula resisting moment upon what, students? It is given by the formula resisting moment upon the factor of safety for rotational failure is given by the formula ratio of resisting moment upon driving moment. It is the ratio of resisting moment upon driving moment. Now, my dear students, what will try to resist and what will try to drive you? Usually the weight which is acting will cause driving moment, and the shear strength of the soil, which will, if the strength of the soil is more, it offers more resistance. If the strength of the soil is less, shear strength is less, it will offer less resistance. Bhuvan, Shabir and Sai Srujana. Are you following, Amma? Okay. Here if you see the cohesion is acting towards like this, and this is trying to resist it. So actually, see, students, the factor of safety using for rotational failure, the factor of safety using phi u is equal to 0 analysis. Okay, the factor of safety is given by the formula C into LR upon W into X bar. What is C here, students? What do you mean by C here? Yeah, very good, Srujana. What is C? C is nothing but the cohesion. What is L, sir? Length of the arc. And what is R? Radius. W is the weight and X bar is the distance. So here this is X bar. If you take this as the point, and you can say this is the radius. Okay, this is the length of the arc. Now see students, if you have a radius r and this is theta, the length of the arc is given by the formula r theta. So using these conditions, you have to solve the problem. So we have different formulas also, students. See, actually we have Bishop's method. See students, I am giving you overview only. I am not going in detail because my agenda is to solve the best problems. We have the Bishop's method. See students, we have Swedish circle method also. Okay. Now see students, in Swedish circle method, there is an important point, sir. In Swedish circle method, if you see the failure surface, I told you, right? If in Swedish circle method, if you consider this as a failure surface, here also the failure surface is a curved surface. If the weight acts downwards and these are resolved into normal components and also a tangential component, better you do at this juncture, sir. So you can understand. Okay, here is the weight component and we have here alpha. So this is W cos alpha, normal component, and this will be equal to W sin alpha. Now see students, here the failure surface is assumed as an arc, but if you consider here, the failures are assumed in the form of slices. Agree? So this is what I would like to tell you. But see important point, students. Here whatever the normal component is passing through the point of rotation. So normal component will not cause any driving moment, students. So the factor of safety for Swedish circle method for C means if there is a water table also, CL into sigma n minus u tan phi upon sigma t. This is the formula for the factor of safety. This is the formula for factor of safety for which method? For Swedish circle method. Very good. Now see students, in Bishop's method, actually Bishop's method is the most accurate method, students. Why Bishop's method is the most accurate method, you can ask me. Why Bishop's method is the most accurate method? See students, whatever you considered here, the failure surface is an arc of a circle. But see students, the forces between the slices, if you see the forces between the slices, this is not considered in Swedish circle method. In Bishop's method, forces between the slices is considered. Hence, it is the most accurate method. Now see students, all these are the factor of safeties for which failure? For rotational failure only. All these are the factor of safeties for which failure? All these things are the factor of safeties for rotational failure. Okay. Now see students, what is the factor of safety for rotational failure? I told you, resisting moment upon driving moment. So if I take Bishop's method, this is the most accurate method, I told you. Bishop's method is the most accurate method. Here we come across the formula C plus sigma tan phi upon Cm by sigma dash, or you can write sigma dash, tan phi m. Now you will come directly ask me, sir, what do you mean by Cm and phi m? Remember students, here Cm and phi m are called as mobilized cohesion. Cm and phi m are called as mobilized cohesion and mobilized friction. What is Cm and phi m? These are called as mobilized cohesion and friction. So what do you mean by mobilized cohesion and friction? As we have considered the forces between the slices, there will be a change in the cohesion and the change in the repose, angle of repose is considered. That is the reason this method is the most accurate method. And one more thing students, we have stability number. Stability number is given by the formula C into Fc into gamma into H. This is the important formula for stability number. And my dear students, they can ask you what is the radius of friction circle. The radius of friction circle is r sin phi. Remember students, in this session, I will give you the basic insight of the chapter and I will solve the problem. So let me conclude the points related to stability of slopes before solving the problem. When you talk about slope failure, there can be the reasons can be earthquake force or seepage force or uplift force. All these can be the reasons for slope failure. There are two types of slopes. One is the infinite slope and other one is the finite slope. In finite slope, my dear students, the slope length is limited. In infinite slope, the slope length is unlimited. And we have two types of failures. One is the translational failure and other one is the rotational failure. Translational failure is observed in infinite slopes and it occurs at some depth parallel to the slope. And remember, my dear students, translational failure, the factor of safety is defined as the ratio of shear strength upon shear stress. Factor of safety is given for the C5 soil as C plus gamma z cos square I upon gamma z cos I sin I. When I talk about rotational failure, it is defined as the ratio of resisting moment upon driving moment. Resisting moment is usually due to shear strength and driving moment is usually due to weight. The first method we have taken is about phi is equal to 0 analysis. The factor of safety is given by the formula C into L into R upon W into X bar, where L is the length of the arc, R is the radius and W is the weight. And the factor of safety with respect to Swedish circle method, here also the failure surface is an arc, but we have not considered the forces. Here the formula is given by CL plus sigma n minus u into tan phi upon sigma t, where sigma n is the sum of the normal forces, sigma t is the sum of the tangential forces, sigma u is sum of pore water pressure or neutral forces. Okay, and we have the most accurate method, Bishop's method. Why do you call it is the most accurate method? Means the forces between the slices is also considered. That is the reason it is the most accurate method. And the factor of safety is given by the equation C plus sigma tan phi upon Cm plus sigma dash tan phi m, where Cm and phi m are mobilized coefficients. Cm will be equal to 2/3 of C and tan phi m will be equal to 2/3 of tan phi. And remember, the stability number is given by the equation C into Fc upon gamma into H. If you talk about critical height, Fc can also be written as Hc upon critical height upon actual height. The radius of the friction circle is r sin phi. Students, if you are really liking this session, before going to the problems, I just want to ask you, just share these sessions. It would be really helpful for the students who are interested for the GATE exam, who are writing the GATE exam for GATE 24. Now see students, we have a beautiful question. In this question, I would like to tell you, the side of a canal is shown in the figure and the properties are gamma sat is equal to 20 kilonewton per meter cube, C is equal to 25 kilonewton per meter square, phi is equal to 0. Okay, it's a pure cohesive soil, then phi is equal to 0. Now let me tell you, the other things we have is the weight which is acting downwards, radius is 8 meter, angle is 96 meter. So what he is asking in the question is, calculate the factor of safety when the canal runs with fully water level at the top of the slope, and the second point is when the canal gets emptied suddenly, and take area of the as 33 meters square. Now let me tell you. So here see students, in this, I would just want to draw the diagram here. One second. As I told you, the factor of safety is what, sir? This is a rotational failure, okay? And it's a pure cohesive soil. So phi is equal to 0 analysis. When phi is equal to 0, the factor of safety for rotational failure, just now I told you, C into LR upon W into X bar, okay? Now see students, if you talk about the radius is 8 meter, angle is how much given in the problem? It is 96 degree, and here you have the weight. and the weight is acting at a distance of how much, sir? 2 meter. If you see the weight, if it is acting, the weight is acting at a distance of 2 meter. So here see students, x bar is equal to 2 meter, and see students, let me tell you, gamma sat is equal to how much, sir? 20 kilonewton per meter cube. Now let me tell you, how do you calculate weight? Gamma sat is equal to what, sir? Gamma sat is equal to weight by volume. Okay, because we have to find out W also, weight. So see students, here weight can be calculated as gamma sat into volume. Now this is very important, sir. In the first condition, in the problem, they have mentioned that canal gets, see here, the water table is at the top of the slope. When canal runs with full water level at the top of the slope, means water table is at top. So when the water table is at top, the condition of the soil is saturated. So here weight can be written as gamma sat into volume, and here you can write gamma sat into volume can be written as area into length. I will calculate for 1 meter. Okay. In the problem, they have given area as 33 meter square. So if you calculate the weight, gamma sat is equal to 20, area is equal to 33. So weight will be equal to 660. Okay. 660 kilonewton. Okay, students, per unit length. Now we have calculated the weight, and x bar is how much, students? 2 meter. Now we have to, they have given the C value. If you see the C value is given in the problem as 25 kilonewton per meter square. And you know from the question, radius is equal to how much, sir? Radius is equal to 8 meters, which is given in the question. Now see students, if you consider as arc, if this is theta and it is having a radius r, okay, what will be this what will be the length of the arc, sir? Here what will be the length of the arc? The length of the arc will be equal to r theta. What will be the length of the arc? The length of the arc will be equal to r theta. So here L is equal to r theta. So radius is equal to 8 meter, theta is equal to 96 degrees into pi by 180. Okay. Can anyone tell me what is the length of the arc, sir? What is the length of the arc which you have calculated? How much value you got, sir? You will get a value of 13.4 meter. You will get the length of the arc is 13.4 meter. Now see students, you have done everything here. Are you getting me? You have done everything. Now see students, here we have taken gamma sat, right? But what is the condition they have told, sir? They have told gamma sat, this is the condition. But see the condition, we have everything, but we have to find out weight also again. Because see, the first case, canal runs with water, full with water at the top. Okay. Now see students, let me tell you very important point. When the water, see, whenever you are calculating the effective stress, I told you clearly in the previous sessions, gamma sat will be replaced by gamma dash. Okay. Here as the water is containing at the top, we have to calculate gamma dash. So for gamma dash, what I will do is, gamma dash is equal to gamma sat minus gamma W. For this condition, we have to calculate the weight based on only gamma dash. Okay. Here gamma sat is how much, students? It is 20. Gamma W is 10. So this will be equal to 10 kilonewton per meter cube. Gamma dash will be equal to how much? 10 kilonewton per meter cube. Actually gamma W is 9.81. For easy calculation, I have taken the value as 10. Now here gamma dash again is equal to weight by volume. Okay, weight can be written as gamma dash into volume. Okay, what is the value of gamma dash, students? Gamma dash value is nothing but 10 and the area is 33 into 1 meter. So this will be equal to 330 kilonewton. So see students, one case when the canal is running full with water level, in this case you have to take this weight. Okay. And why you have calculated this weight, you can ask me. Sir, see, very important point. In case of sudden drawdown, there is a word called in case of sudden drawdown, or when the canal gets emptied suddenly, in that case we will take gamma set. Here we will calculate the weight taking gamma set. When the canal is running fully with water level, then we will take weight, then we calculate the weight using gamma dash. So here see students, here if I talk about the factor of safety, in the first case is when the canal runs with full with water level. So here the formula is given by the formula C into LR upon W into X bar. Okay, here you will get cohesion is equal to 25, length of the arc is 13.4 meter, and radius is how much, students? Radius is nothing but 8 meter. Are you following, students? Here see, in the first case, canal is running full with water level. When the canal is running with full with water level, in that case you have to take the value which you have considered using gamma dash. So here it is, weight is 330, which you have calculated with respect to gamma dash. X bar is 2 meter. When you solve this, you will get a factor of safety as how much, sir? You will get the factor of safety as 4. So the factor of safety for rotational failure is, this is the formula for phi is equal to 0 analysis. And when the canal is running full with water level, then we will take gamma dash into picture and we will calculate the weight. After this, what we will try to do is, when the canal gets emptied suddenly, I told you the same formula, but the weight will change, because when the canal gets emptied suddenly means it is a sudden drawdown condition. In sudden drawdown condition, whenever you are calculating the weight will be calculated with respect to gamma sat. So here the same formulas, we have to plug in the same values. 25 into length of the arc is 13.4 into radius is how much, students? Radius is 8 meter, and here see, students, what is the weight we have to substitute? The weight value will be equal to 660, which is the value which you have considered using gamma sat. This is the value which you have calculated using gamma sat. Into X bar is how much? X bar is 2. So if you solve this, you will get approximately the value as 2. So remember, students, when the water is running at top, you have to take extra factor of safety, so 4. When the water is getting emptied suddenly, the factor of safety is 2. So what I would like to tell you is, when the water is at top, it is more dangerous. So that is the reason you are providing more factor of safety. So what are the key points from this problem is, first thing is, from phi is equal to 0 analysis, we have factor of safety for rotational failure is given by the formula CLR upon W into X bar. Here the weight is calculated based on the conditions. When the canal runs full with water level, weight will be calculated by using gamma dash. When the canal gets emptied suddenly, weight will be calculated as using gamma sat. X bar is the centroid, C is the cohesion, L is the length of the arc, R theta. Here if you want to convert into radians, students, see here if you want to convert into radians, you have to multiply with pi by 180. So that's how you have to calculate the length of the arc, and you have to plug in these values. I hope you are clear. Now see, students, this is one of the previous year gate question also. A fully submerged infinite sandy slope, and remember my dear students, when they used the word infinite word, when they have used the word infinite means you should immediately think that there is a translational failure. Based on, if it is a finite slope, then you will see rotational failure. If it is an infinite slope, then you will see it is a translational failure. So they have given inclination is how much, sir? 30 degrees and 18 kilonewton per meter cube. Effective angle of internal friction is 38 degrees. Okay. Saturated unit weight is 18 kilonewton per meter cube. Assume the C phase is parallel to the slope. Again he is telling, assume the C phase is parallel to the slope. Again a shear failure. What is the factor of safety? So my dear students, he is asking clearly the factor of safety. So here when I see here, as it is an infinite slope, as it is an infinite slope, you can clearly say that as it is an infinite slope, you can clearly say that it is translational failure will occur. Which failure will occur? Translational failure will occur. Okay. Now see students, in case of translational failure, okay, the factor of safety is given by the formula, if you remember, C plus gamma z cos square I into tan phi upon gamma z cos I sin I. Agree? Now see students, he might have given in the problem, it is a sandy soil. Sir, see, here it is a sandy soil. So what is a sandy soil? Remember I told you already, gravel and sandy soil means it is a cohesionless soil. Sandy soil indicates it's a cohesionless soils. So cohesionless soils means C will be 0. Okay, and one more thing, he has asked the factor of safety with respect to, means there is a seepage occurring parallel to the slope. Whenever there is a seepage, the factor of safety with respect to the seepage, which is an important formula, the factor of safety with respect to seepage is given by the formula gamma dash upon gamma sat into tan phi upon tan I. Okay. See students, this I told you already, this is the most important formula. Here gamma sat is given in the problem. How much it is they have given you? 18 kilonewton per meter cube. Okay. So here gamma dash will be equal to what, sir? Gamma dash will be equal to gamma sat minus gamma W. So here this value will be equal to 18 minus 10. I am assuming gamma W as 10 for easy calculation. Okay, actually it is 9.81 kilonewton per meter cube. So gamma dash is equal to 8. So here you can write in this formula gamma dash is 8, gamma sat as 18, phi angle of internal friction is 38 degrees divided by angle of infinite slope is how much, sir? 30 degrees. They have given this, how do you know 38 degrees, sir? 38 degrees they have given 5 values 38 and angle of infinite slope is 30 degrees. Now please let me know what is the answer. Sir, if you see, the factor of safety will be 0.6. Okay. Clear, sir? Is this clear, students? Okay. Next. Now see students, let me tell you, we have a concept called earth pressure. What, sir? We have a concept called earth pressure. Now let me tell you the basics of earth pressure. Sir, see, if you consider as a retaining wall, suppose if I consider this as a retaining wall, there can be a wall movement. If I consider this as backfill, if I consider this as retaining wall, the wall can move in this direction, or the wall can move in this direction, or the wall can remain stationary. So see students, based on the movement of the wall, based on the movement of wall, based on the moment of wall with respect to backfill, based on the moment of the wall with respect to backfill, how do you classify the earth pressure, sir? So if I consider this part, whatever this part is backfill, so whatever, how the wall is going to move, whether it is moving away or towards, or if it is stationary, based on the wall movement, how the earth pressures are classified. So see students, first one we have is the at rest pressure. First one we have is the at rest pressure. Second one we have is the active earth pressure. And third one we have is the passive earth pressure. Third one we have is what, sir? passive earth pressure. So my dear students, based on the wall movement, earth pressures are classified into three types. Very good, Swetanshu. At rest pressure, active pressure, and passive earth pressure. Now see students, actually let me tell you before going to the explanation of this concept. Okay, now let me tell you one important thing. Actually, if we consider a wall or anything, usually we are having the vertical stress calculation. But what is earth pressure? Earth pressure is always the horizontal stress. They are always the horizontal stress. So see students, it is quite simple. Suppose if you have a resultant, F, okay, and if he is having theta, what will be the horizontal component? You will write it as F cos theta and F sin theta. So similarly, see students, to resolve the vertical stress into the horizontal stress, we required a coefficient that is called coefficient of earth pressure. That is called what, sir? Coefficient of earth pressure. So what is the function of coefficient of earth pressure is, or what is the intention of this coefficient is, it just, what it will try to do is, it will try to convert the vertical stress into horizontal stress. So K is equal to sigma H upon sigma V, where you can calculate horizontal stress is equal to K into sigma V. Here K indicates the coefficient of earth pressure. Agree students? What is K indicates? K indicates the coefficient of earth pressure. Now before moving to the next point, sir, see, I would like to tell you here what is at rest pressure, what is active pressure, and what is passive earth pressure. So we have three things. One is the at rest pressure, active earth pressure, and passive earth pressure. Now when I talk about the at rest pressure, in the name itself, at rest pressure. See students, you can ask me, sir, why you are giving the explanation? In one of the GATE exam, they have not asked calculate earth pressure, active earth pressure, calculate passive. No, they haven't asked like that. They have asked with some other meaning. That we'll see. At rest pressure means no wall movement. What is the wall? At rest pressure means there will be no wall movement. Okay. Now here in active earth pressure, the wall movement is away from backfill. Okay. If you talk about passive earth pressure, the wall movement is towards the backfill. Are you getting, my dear students? In active earth pressure, there is no wall movement. Here in active earth pressure, the wall movement is away, and here the wall movement is towards. Now, as there is no wall movement in at rest pressure, we will be using elastic equilibrium condition. As there is no wall movement, what is the condition we are using in at rest pressure? We are using the elastic equilibrium condition. But in active earth pressure, students, as the wall is moving, means there can be a disturbance in the soil. So here we use plastic equilibrium condition. Sir, here also we use plastic only. Why? Because whether it is towards or away, but there means that there is a wall movement, right? So that is the reason we will use. Now the most important point, as there is no wall movement, there will be no yielding of soil mass. What, sir? In at rest pressure, as there is no wall movement, there will be no yielding of soil mass. Next, in active earth pressure, see students, when the wall, suppose if I consider a small equilibrium element, if the wall is moving away, you will try to balance it. If the wall is moving towards away from you, you will try to pull it to balance it, right? So here, see students, here yielding occurs due to, what is this symbol indicates? Here yielding is due to tension. Here yielding is due to tension. And remember, in passive earth pressure, yielding is due to compression. Sir, this line is important. Whatever I have written here, this line is important. Why this line is important, I will tell you students. Remember simple logic, they will not give you the name of the earth pressure. Calculate the earth pressure when there is no yielding of soil mass. When that means it is at rest pressure. Calculate the earth pressure when there is a yielding of soil mass due to tension. Then it is active earth pressure. Next they can ask you, calculate the earth pressure when there is an yielding of soil mass due to compression. Then it is passive earth pressure. Agree? So here the most important thing is coefficients. If you see the coefficient of at rest pressure, K naught is equal to 1 minus sin phi. Okay, these are very, very important, sir. K naught is equal to 1 minus sin phi and Ka is equal to 1 minus sin phi by 1 plus sin phi. What is Ka? Coefficient of active earth pressure is equal to 1 minus sin phi by 1 plus sin phi. And what is Kp is equal to 1 plus sin phi upon 1 minus sin phi. See students, for your easy understanding, see, this is the basics how you have to distinguish at rest pressure or active pressure or passive pressure. At rest pressure means no wall movement. Active pressure means wall movement is away from the backfill. Passive earth pressure means wall movement is towards the backfill. These are the 3 points you should remember. Okay, now see students, if I talk about the relative magnitudes, okay, if I talk about the relative magnitudes of, if I talk about relative magnitudes of, if I talk about the relative magnitudes of earth pressure. See students, I can explain you with the mathematical relation also. Okay, just let me tell you the practical application of. Okay, when I talk about the relative magnitudes of earth pressure, now see students, here what I would like to tell you is, the graph will be somewhere like this, okay. If I take here, if I take this is the wall movement, here if I consider this as wall movement, okay. If the wall movement is, this is no wall movement, okay. Here we can write this as wall movement is towards, right. Here no wall movement K naught, and here the wall movement is toward, away from the backfill, then it is Ka. So see students, here you can write it as wall movement. So when I talk about the relative magnitudes, here you can understand that Kp is greater than K naught greater than Ka. So this is how you define the order of the earth pressure. Now what is the formula of Kp? 1 plus sin phi by 1 minus sin phi upon 1 minus sin phi greater than 1 minus sin phi greater than 1 minus sin phi upon 1 plus sin phi. Sir, simple logic. Which is the highest value in the numerator, sir? 1 plus sin phi. Which is the least value in the denominator? 1 minus sin phi. That is the reason Kp is greater. When you compare these two equations, denominator is 1 plus, so it is more than 1. Here if you consider denominator, it will be 1. So that is the reason K naught is greater than Ka. So remember students, when I talk about the relative magnitudes of earth pressure, Kp is greater than K naught greater than Ka. So these are the relative magnitudes of the earth pressure. And now let me tell you one important thing. Active pressure, very good Swetanshu. Now where do you apply this? If we consider the design of retaining walls, we use active earth pressure. The application, please understand, sir. In the design of the retaining walls, we will be using the active earth pressure. In case of basement walls or bridge abutments, we use at rest pressure. And passive earth pressure is used in case of sheet piles. Sir, sheet piles are nothing but to protect the waterfront structures in the harbors from the ships. Okay. So sheet piles are with huge pressure. That is the reason we are using the higher value, that is passive pressure. Okay. Now, let me tell you some important steps to solve the problem. Sir, see, if you follow these steps, it will help you to solve any problem on earth pressure. So these steps you have to follow for steps to follow to solve problems on earth pressure. Okay. The first step is every time, whether it is an active pressure or passive pressure or at rest pressure, first step is calculate the respective coefficient of earth pressure. Calculate the respective coefficient of earth pressure. Okay. Now see students, after finding the coefficient of earth pressure, the next point you could calculate, you can write is, you have to draw or you don't require to draw, or you can draw. Our next point you have to write is calculate the vertical stress. Okay, sigma V is what, sir? Calculate the vertical stress. Now see students, let me tell you one important thing. Sir, this is a very important point. When you are calculating the vertical stress, in case of pore water pressure, always total stress should be written as effective stress plus pore water pressure. What, sir? I will tell you very important reason. Whenever you are calculating the total stress in case of earth pressure problems, every time you should write it as effective stress plus pore water pressure, because the coefficient of earth pressure is equal to 1 for pore water pressure. So you cannot multiply Ka into sigma V if there is water table. It has to be separated, and for pore water pressure, don't apply the coefficient or don't multiply with the coefficient. Why? Because Pascal's law states that pore water pressure is same in all directions. That is the reason we need not to multiply K and vertical stress. So that is the reason again and again I am telling you, according to the Pascal's law, pore water pressure is same in all directions. Hence, we need not to multiply the coefficient of earth pressure for pore water pressure. And the important point I would like to tell you is, whenever there is a water table, you have to write the total stress as the summation of effective stress plus pore water pressure. The third step will be earth pressure diagram. How do you calculate earth pressure diagram? So you have to draw the earth pressure. Okay, earth pressure with the diagram. Okay. Now let me tell you how do you calculate. After finding the earth pressure diagram, the fourth step is area of the pressure diagram. Area of pressure diagram. Can you tell me, sir? Pressure into area is what? Area of the pressure diagram will be equal to what, sir? It is nothing but the force. And the fifth step I would like to tell you, my dear students, the fifth step is nothing but, okay, the force acts at its centroid. Where does the force acts? The force acts at its centroid. So these are the basic steps. First step is calculate the coefficient of earth pressure respect to earth pressure. Second one is calculate the vertical stress. If you have water table, write the total stress as effective stress plus pore water pressure. Third step is draw the earth pressure diagram. I will tell you how to calculate earth pressure for cohesive soils, cohesionless soils and all. Area of the pressure diagram is force, and the force will act at its centroid. Agree? Is this Okay. Now let me tell you the important formulas. Active earth pressure for cohesionless soils. I am telling you, sir. For cohesionless soils, what is PA indicates? PA indicates active earth pressure. It is equal to Ka into sigma V. Okay. And passive pressure, P, is equal to Kp into sigma V. Okay. And at rest pressure, it will be equal to K naught into sigma V. So these are the active earth pressures. Okay. If you talk about the force, see students, actually, if you consider here sigma V means what, sir? Gamma into Z. Okay. And if I consider this as Z as the depth of the soil, what will be the at rest force here? F naught means area of the pressure diagram. So half into K naught, base is K naught into gamma into Z, depth is Z. So this will be equal to half into K naught into gamma Z square. So this is the at rest force. Similarly, if they ask you active passive force, half into Kp into gamma Z square, where Z is the depth of the soil strata. And what is the F naught value? Half into K naught into gamma Z square. So remember students, all these are the pressure diagram formulas for what, sir? These are the formulas for what? These are the formulas for active pressure and active force, passive pressure and passive force, and at rest pressure and at rest force for cohesionless soils. Okay, please go through this formula, students. Clear, sir? I hope you are clear. This, okay. Next, active pressure for cohesive soils. Or sir, active pressure for cohesive soils. For cohesive soils, see students, active pressure is given by the formula Pa is equal to Ka into sigma V minus 2C root Ka. Okay. Next, similarly, passive pressure is equal to Kp into sigma V plus 2C root Kp. Okay. So these are the active pressure and passive pressure formulas in case of cohesive soils. Now see students, I would like to tell you active force is given by the formula, okay, half Ka gamma h square of Ka gamma Z square or H square, where Z is the depth of the soil strata, of Ka gamma Z square minus 2C root Ka into Z. This is the active force formula in case of what, my dear students? In case of the cohesive soils. Similarly, if I talk about the passive pressure force, it will be equal to half into Kp into gamma Z square plus 2C root Kp into Z. So see students, here these are the active force and active pressure formulas in case of cohesive soils. Now see students, we have a concept called tension crack depth. What is tension crack depth is? It is the depth at which, simple logic students, it is the depth at which active pressure is 0. The depth at which active pressure is 0 is called tension crack depth. And a very, very important formula. It's my sincere request. You have to remember this. It is the depth at which active pressure is 0 or ZC is equal to 2C by gamma root Ka. So this is the formula for tension crack depth. So what is tension crack depth? It is the depth at which active pressure is 0. Very good, Shwetanshu. Next, similarly, we have critical height. Critical height is equal to 4C by gamma root Ka. What is critical height, sir? Critical height is equal to Hc is equal to 4C by gamma root Ka. What is critical height, sir? It is the height at which active force is 0. Here active pressure is 0. Here active force is 0. So critical height is equal to Fa is equal to 0. Then you will get 4C by gamma root Ka, or you can write this as 2 into Zc. And remember, students, the difference in active force before and after formation, you can write, sir, the difference, everyone please write down, this is also another important point. The difference in active force before and after formation of tension crack is given by the formula 2C square by gamma. What, sir? The difference in active force before and after formation of tension crack is given by the formula 2C square by gamma. Very good, student. Okay. Now, see, I have given you the entire insight of the earth pressure problems. So let us solve the problem, student. So this is also one of the previous year gate questions, students. Just go through the question for a minute. Okay. I want everyone to go through this question. So see here, students, a 3-meter high vertical earth retaining wall retains a dry granular soil. Sir, I used the word dry granular. If they have used the word dry granular, here it is a cohesionless soils and C will be 0. With an angle of internal friction, how much, sir? With an angle of internal friction, 30 degrees. And unit weight of 20 kilonewton per meter cube. If the wall is prevented from yielding, or they have given no movement. What is wall? No movement means what, sir? What is the total horizontal thrust kilonewton per unit length? So this question will be asked, sir, whether we have to calculate which pressure. So he has told no wall movement. Very good, Shwetanshu. If they have told you there is no wall movement, then it is called what, sir? At rest pressure. When they are saying it is no wall movement, it is an at rest pressure. And they are asking what is the total horizontal per unit length. So definitely it will be the force. If they give you kilonewton per meter square, then it is the pressure. If they have give kilonewton per unit length, then it will be obviously force. So here see, student. So first step is what we have to do. First step, what I have told you, it is an at rest pressure. So we have to calculate K naught. So what is the value of K naught? K naught is equal to 1 minus sin phi. So what is here? 1 minus sin phi means 1 minus sin 30 degrees. 1 minus sin phi means 1 minus sin 30 degrees. So K naught value is equal to what, sir? 1 by 2. Now similarly, the second step what I have told you is sigma V. So here when I calculate sigma V, what is the unit weight, sir? 20 and the wall is 3 meter. Sigma V can be written as gamma into Z. Okay, gamma into Z. So gamma value is given as 20 and Z is 3. So if you see the vertical stress distribution diagram, here it is 20 into 3. So here it is 0. So sigma V is 60. Now we have to multiply these two to get the earth pressure. Are you following, students? Okay, so here we have to find out the pressure diagram. So you can write here at rest pressure. So here if I write at rest pressure here, what will be the at rest pressure, sir? See, students, here you have 0. Okay, here I have to write Ka into sigma b. What is Ka? Half into 20 into 3. So this will be equal to 30. And what is the depth of the soil strata given in the problem? It is 3 meter. Okay, but what they have asked you in the problem, students? They have asked you force. So force is equal to what, students? Force is nothing but area of pressure diagram. What is force? Area of the pressure diagram. So how do you calculate area? Area of triangle, how we calculate? Half into base into height. So you can write it as half into 30 into 3. So this will be equal to 45 kilonewton per meter. So see, students, what are the key points? So the answer will be here is how much, sir? Here you can write the answer here is option C, 45 kilonewton per meter. So what are the key points in this problem? Let me tell you. So here in the first one, what we have to calculate, sir? We have to calculate the coefficient of at rest pressure. How do you calculate the coefficient of at rest pressure? K naught is equal to what? 1 minus sin phi. Okay, similarly, what do you mean by vertical stress? Vertical stress is nothing but gamma into Z. And how do you calculate the C? You have to first calculate the coefficient of at rest pressure, that is K naught is equal to 1 minus sin phi, and vertical stress is gamma into Z. After finding that, you have to multiply those two equations to get the pressure at the bottom. And the area of the pressure diagram is nothing but the force. So these are the key points which you will be calculating in the problem. Now, see, we have another question from stability of slopes, sir. So see, students, what is the question? I would be very happy if anyone solve this problem. So the soil profile above the rock surface for a 25-degree infinite slope is shown in the figure, where SU is the undrained shear strength. One is having 40 and other is having 60. The slip will occur at a depth of. So please go through this question, students. I'll give you 1 minute of time. Okay students, are you solving the problem? So here they have not given the phi value, but they have given the slope angle as 25 degrees. So see students, in this what they are asking is the slip will occur at a depth. So you are not sure whether the slip will occur in this zone. See student, you are not sure whether the slip will be occurring in this zone or whether the slip will occur in this zone. So here what I will do is, we have to go with the assumption base. Okay. See students, here what I would like to tell you here is, here phi we will assume as 0. Okay. And why phi is equal to 0? In this case, what is the factor of safety for translational failure? We have C by gamma z, because gamma z cos square I tan phi. Tan phi value will be 0 and gamma z cos I sin I. So we assume that the factor of safety means it is occurring in the top surface, or we will assume at this surface which is at 5 meter depth. Okay. So here what is the cohesion value they have given? What is the cohesion value they have given, sir? 40 kilonewton per meter square. Yes or no students? In the first case they have given 40 kilonewton per meter square. So we have just apply 40 divided by gamma value is in the first case. Gamma is how much, sir? 16, and the depth is 5 meter. So 60 into 5 into cos 25 degrees into sin 25 degrees. Students, if you are confused, actually let me tell you the things also. If you are just, you know the factor of safety is what, sir? C plus gamma z cos square I tan phi upon gamma z cos I sin I, right? Here what is happening is, in this equation phi will be 0. So this part will be equal to 0. So only this part we have taken into consideration. If you calculate this, what is the value you got, sir? You will get value of 1.3. Sir, see, if the value is more than 1.3, let me tell you, if the value is 1.3, that means it is greater than 1. So this value is greater than 1. So you can simply say that the value means the slope will not fail in this in the upper part, in this region. So the failure will be in the bottom part only. So for that, what I will try to do is, if we consider this as a surface, okay, are you following, students? If we consider this as a surface, what we have to do is, this is 5 meter and here is also 5 meter. Okay, so what I will try to do is, I will try to assume some depth from here, which is the depth from top as x. Okay, sir, see, for the slip to occur, it should be a critical condition. Sir, see, for a slip to occur, it should be a critical condition. In a critical condition, remember students, in a critical condition, the factor of safety will be equal to 1. So here, see students, we have two things. One is what, sir? Here gamma is equal to how much they have given value? 16, if I am not sure. Let me check it. Gamma 16 we have, S is 40. Here we have gamma is equal to 20. Here S is equal to 40 and here S is equal to 60. Am I correct or wrong? So in critical condition, what is the factor of safety we will be taking, sir? We will be taking the value as 1. Now see students, what I will do is, I will assume somewhere here. So the factor of safety formula here is what? C upon, now see students, here the values will change, sir. So from the distance from here to here is how much, sir? The distance from top to here is x. So you can write somewhere, generalized formula I will write like this, sir. Gamma z1 plus gamma 2 into z2 into cos I upon into sin I. So it is occurring in which layer, sir? You are occurring in the second layer. You are assuming that it will occur in this layer. So we will take S value, C value as 60 only. Okay, 60 divided by gamma is how much, sir? 16 into 5. In the first case, it is 16 into 5 plus, in the second case, what is the gamma value? 20 into, what will be this depth, sir? What will be this depth? Sir, from top to here, it is x. So, what will be this depth? This depth will be equal to x minus 5. Whichever is the top, we will minus that. Am I correct or wrong, students? Here it is 5. From here to here, it is x. So, this value will be equal to x minus 5. So, just plug in this value. X minus 5 into cos I is how much, sir? Cos 25 degrees and also sin 25 degrees. So, if you solve this, what will the value of x? Just solve the student, just solve that problem. So, you have to take factor of safety as how much, sir? 1. Why we are taking 1? Because it is a critical condition. Taking the factor of safety as 1 and cohesion as 60 because it is in the second layer, and we have assumed the distance from top as x. Now, calculate the value of x. If you see, students, if you calculate the x value, you will get the value of x is equal to 8.83 meter. Okay, from top. So, if you see the solution here, x is equal to 8.83 from top. So, option A is correct. So, see, students, here I will tell you what are the key points in this problem. Let me tell you. The key problem here is, first of all, it is a sandy, so first of all, it is a clayey soil because it's a pure cohesive soil. So, phi is equal to 0. In pure cohesive, sir, remember these 2 points are very important. In case of gravel and sand, they are called as cohesionless soils. So, C will be 0. And when I talk about pure cohesive soil, phi value will be equal to 0. Here the factor of safety for translational failure is given by the formula C plus gamma z cos square I into tan phi upon gamma z cos I sin I. This is the formula for factor of safety for translational failure. Now, see here, when I talk, this is the formula for factor of safety. Now, in this problem, if they have asked, we have 2 different layers, sir. In the 2 different layers, the vertical stress will be taken as gamma 1 Z1 plus gamma 2 Z2. If we are habituated for 1 layer, we are taking gamma into Z. But if there are 2 layers with 2 different depths, then you have to take gamma 1 Z1 and gamma 2 Z2 when the values of unit weights or if the soil is in the form of a strata. If you can apply and plug in these values, you can solve this problem. Another important point, key point in this problem is, where will the slip occurs means it is about to fail. When it is less than 1, it will fail. So, you have to say that at a critical condition, factor of safety as 1. And if whatever the value means at that depth, it is about to fail. If it crosses that depth, then slip will occur. Students, I hope you are enjoying this session. See, students, we at IMS Gate Academy have a experienced faculty and a very good team of faculty pool for especially for civil engineering, and we are here to explain you the concepts on civil engineering. Okay, for every branch, and we have a separate program like Gate Score Booster. So students who have already known their concepts, if they want to brush up their knowledge, if they want to practice their best of their knowledge, then IMS Gate Academy platform, just watch our videos, and if you have really liked these videos, please like and share. And I also have told you in the first that we are providing a Telegram group. In the link, in the description, they have given the Telegram link. Just click on the link and join the Telegram group, and definitely you can access all the notes, which is very important. After completing the session, if you want to access the notes, then definitely in the Telegram group, we are giving you that access. So that is how I am going to tell. Now see, students, we have the next question. Please read this question, students, anyone. So here the question is, a smooth vertical retaining wall supports a layered in soil shown in the figure. According to the Rankine earth pressure theory, the lateral active earth pressure at the base of the wall. So see, students, what is asking, sir? He is asking the active earth pressure He is asking what is the active pressure at base. Sir, see students, when they ask you the active pressure at base, okay, they are asking what is the active pressure at the base. In this case, you should be smart. You need not to find out Ka1. If they give you the friction angle is 32 degrees, no need to find out Ka1 here. Okay, here if you see students, I just want to tell you here, if you see Ka1 is not required at all because they have asked the value at the base. So you have to take the angle of internal friction as 25 and you have to solve the problem. Okay, so in this way you can save your time. That's what I want to tell you, sir. So see students, first one we have is phi is equal to 25 degrees. So what I told you, the first step we have to calculate K at a base. Okay, at a base phi is equal to 25 degree. So what will be the Ka formula? Ka is equal to 1 minus sin phi upon 1 plus sin phi. That is equal to 1 minus sin 25 degrees upon 1 plus sin 25 degrees. So what is the values we have, sir? Ka is equal to, what is the value we have? 1 minus sin phi upon 1 plus sin phi. So here you can write Ka is equal to 1 minus sin 25 upon 1 plus sin 25. Clear? So what is the value of Ka, sir? Can anyone tell me? Sir, if you see here, Ka value, if you calculate, you will get a value of 0.458. Okay, this is the value of Ka. Now see students, to calculate the active earth pressure. Sir, see, to calculate the active earth pressure for cohesive soils. To calculate the active earth pressure for cohesive soils. Okay, the active earth pressure, Pa, is given by the formula Ka into sigma V. This was a GATE 2023 question, students. Ka into sigma V minus 2C root Ka. So this is the formula. Okay. Now see students, we have calculated Ka, but we have to calculate sigma V here. So what will be the sigma V? So see students, there is a surcharge load of how much, sir? 20. And we have 18 into 3 meter and 19 into 4. Sir, see, surcharge load is how much, sir? You can write it is 20 plus, here, what is this value? 18 into 3, this value only. So this value will be total. This is 54 and this is 20. You need not to find it this also. This is 74. But here they have given, this is 74. From here to here it is 74, but we have to know the value at base. Because in the problem they have done for base. So it is how much, sir? 19 into 4 meter. So 19 into 4 is 76. So total value will be equal to how much, sir? Sigma V is equal to 150. Because 74, 19 into 4, see, it is 76. And remember, you should observe there is water table or not. If water table is present, then the total stress should be always written as effective stress plus pore water pressure. So here see students, so here what is the value you have? Here you have the value of 0.58 and what is the value you got there? 150. So see students, here active pressure Pa is given by the formula Ka into sigma V minus 2C into root Ka. What, sir? Ka into sigma V minus 2C into root Ka. So Ka is equal to how much, sir? 0.458 and sigma V is how much? We got 150. Now see students, what is the C value you have to take? Sir, if there are two C values, but what is the value at base only we have to take. So C value is 20. So you have to take minus 20 minus 2 into 20 into root Ka. Root Ka is how much, sir? 0.58. Now can anyone tell me what is the answer you got? What is the answer you got, Amma? What is the answer you got? Please respond in the group. Please respond in the chat box, sir. What is the answer you got? What is the answer you got, students? You will get an answer of, can you check this? Have you got this answer? 35.39 kilonewton per meter square. You got 41.62. Okay. Sir, 0.458 into 150 minus 2 into 20 into, okay, if everyone got that value, so we will write 41.62 kilonewton per meter square. Okay. (54, 20, 74). Very good, sir. Very good. Now see, solve this problem, students. Very good, Bhuvan. Very good. So here we have two different soils are shown in the figure. The effective cohesion, the resultant active force is asking the resultant active force. Please solve this problem. I'll give you 2 minutes of time. Just read the question, students. Please read the question and we'll start. Okay, just okay, see students, here see, first of all, you should understand, in the first case, phi is equal to 30 degrees, in the second case, phi is equal to 40 degrees. But he is asking first thing, sir, see, whenever these kind of problems are asked, first calculate Ka1. Ka1 is equal to how much, students? 1 minus sine 30 upon 1 plus sine 30. So this value will be equal to how much, sir? Ka1 value will be equal to how much? It will be equal to 1 minus half upon 1 plus 1 by 2. So it will be 1 by 3, or you can write it as 0.33. Okay. Similarly, see students, what will be the value of Ka2, sir? What will be the value of Ka2, students? Ka2 will be equal to what, sir? In the second layer, 1 minus sine. Sir, what is the value they have given here? See here, they have given us 40 degrees. Yes or no? So you can write here 1 minus sine 40 upon 1 plus sine 40. 1 is what, sir? 1 minus sine 40 upon 1 plus sine 40. So what is the value you got, students? Very good, Swetanshu. Very good, Swetanshu. Very good. So what is the value you got? Ka2, how much you got, sir? Okay, very good. Very good, Swetanshu. So you will get here 0.217. Everyone, Ka2 is how much, sir? 0.217. Now see students, here in this case C is equal to 0. In both the cases C is equal to 0. First we have calculated Ka1 and Ka2. Okay. Next. Students, sorry. Now see student. Here what is gamma? 15 and it is 2 meter, 20 and 2 meter. So vertical stress is equal to how much, sir? So if you see the diagram, vertical stress diagram, it is, here it is equal to how much? 15 into 2. So 30 kilonewton per meter square. This is at middle layer. And at bottom, see, what will be the value, sir? It is equal to 20 into 2 meter. So 20 into 2 meter, that will be equal to 40 kilonewton per meter square. So this is the vertical stress. Now see students, you should be smart here. Okay, now I'll draw the earth pressure diagram. Now if you see the earth pressure, sir, see, top value will be how much, sir? Here it will be 0 because 0 into K1. Here it is 30 into 1 by 3. K1 is how much, sir? 30 into 1 by 3 is 10. And up to here, the height is how much, sir? It is 10 meter. And 30 into another value is how much, sir? 0.217. Can you tell me, sir, 0.217 is a lesser value. So here you will get 30 into 0. This value is how much? 10 you got. So this is pressure diagram. What is this value, sir? 30 into 0.217. Can anyone tell me what is the value you got? So you will get 6.51 here. How you got 6.51 here? You can write 30 into 0.217. So 2.17 into 3, it is 6.51. Very good. After calculating this, what I will do? I will calculate the bottom value. What is the bottom value, sir? Here see students, this is important. Here bottom value means this part is 40 we have. Sir, see, 20 into 2 is what? Only this part. We have this part is how much, sir? 30. So total value will be how much here? 30 plus 40. That is equal to 70. Right? Yes or no, students? So the total stress at bottom is 70. So you have here, what is that value? 70 into 0.217. What is the value of 70 into 0.217? What is the value of 70 into 0.217? So it is 2.17 into 7. So 14 and 1 point. So it will be 15.119. Yes or no, students? Is this clear, sir? 70 into 0.217 into 2.217, it is 17 into 7, 70, 49, 119, so 15. So you will get 15.119. Now see, students, the area of the pressure diagram. Area of the pressure diagram, to be more precise, you got a value like this. How much, sir, here? It is 10. Here it is 6.51. And here you got how much, sir? What is the value you got, everyone? Very good. 15.19. Okay. So this depth is how much? This depth is 2 meter. And this depth is 2 meter. So see, students, if you calculate this as the area, so this area is equal to half into 2 into 10. So this value will be equal to 10. So A1, if I take the area of A1 as how much, sir? 10. What will be the area of A2? A2 will be equal to what, sir? Half into 2 into 6.51 plus 15.19. So 2 cancel, it will be 6 plus 15, 21. So it will be equal to 21.7. Sir, what I have done here is, it is a trapezoid, students. Sir, see, students, if you have a trapezoid with the two sides A, B and a height h, okay, the area of trapezoid is equal to half h into A plus B. So the same formula I have applied here. Height is equal to 2 meter, top width is 6.51, bottom width is 15.19. So I have just plugged in that values and I have secured 21.7. So this is area. So total area will be area of the pressure diagram. Total area of the pressure diagram is equal to force. That is equal to 10 plus 21.7. That will be equal to 31.7 kilonewton per meter. So this is the final answer, students. Okay, see, let me tell you one important thing, students. In this problem, we have seen two soil strata with different unit weights. When two soil strata with different unit weights are came, you have to be careful in drawing the pressure diagram. If suppose here, see students, here Ka1 is greater than Ka2. Okay, let me go to here what happened, sir? Ka1 is greater than Ka2, right? So the diagram has came in this way. In suppose, see students, if Ka1 is less than Ka2, okay, then the diagram might vary. Then the diagram varies in this way. Okay, so you should be aware and smart how to draw the earth pressure diagrams. Sir, aware and smart means you have to just calculate the values. If your top value is more, then you will draw. If the bottom means if you have taken this Ka2, if it is less, it comes inside. If it is more, it goes outside. So this is the basic thing where you have to understand. Okay, next see students, next we are entering into the most important topic, that is shallow foundation. See students, there are three mantra. If you follow the three mantra for any GATE exam or for any competitive exam, you will be in a limelight and you will be in a best position to secure a better rank. How it is possible is, first important step is, for every subject, try to make a conceptual notes and it should be a short notes of 20 pages. After the short notes preparation, prepare a formula sheet for the entire subject. And the third one is, write the key points, whatever you have solved in the previous 20 years of GATE questions, or whenever you are solving a beautiful question in any chapter book or exercise book or any material, try to take the key point and plug into your notes. If you follow these three steps and if you can spend some time on a valid time, then definitely you can secure a better rank. So let me go through the shallow foundation, students. What do you mean by a shallow foundation? See students, if depth is less than or equal to width, a foundation is said to be shallow if I consider this as the depth of the foundation and if I consider width of the foundation as B. So here what I would like to tell you is, if depth is less than or equal to width, I would like to tell you what, students, if depth is less than or equal to width, then what I could tell you is, then it is a shallow foundation. If depth is less than or equal to width, then what is the foundation, sir? Then it is a shallow foundation. Now see students, when do you say that a foundation is shallow, or when do you say that a foundation is shallow is, a foundation is said to be shallow if rotational failure is possible. What, sir? A foundation is said to be shallow if rotational failure is possible. Okay, see students, here I don't want to go in detail. There is some things like in Terzaghi, general shear failure, local shear failure and all. Okay, now see students, Terzaghi has given a formula, sir. Terzaghi's theory. Now see student, Terzaghi's theory for ultimate bearing capacity. You should be aware of these formulas. QU for circular footing. Circular footing, it is given as 1.3 CNC plus gamma D NQ plus 0.3 gamma B N gamma. So this is for circular footing. See students, if they have not mentioned anything, the type of footing, then you have to assume as a strip footing. Okay. See students, here NC, NQ and N gamma are called as Terzaghi bearing capacity factors. What are these called? Terzaghi bearing capacity factor. NC is a Terzaghi bearing capacity factor due to cohesion. NQ is a Terzaghi bearing capacity due to surcharge. N gamma is due to weight, unit weight. And remember, see students, all these factors are function of phi only. They depend only on angle of internal friction. Okay. So see students, When phi is equal to 0, you should remember the values. NC is equal to 5.7, NQ is equal to 1, and N gamma is equal to 0. So in case of phi is equal to 0, you have to remember. In other cases, they will mention you in the problems. So this is a circular footing. The ultimate bearing capacity for square footing, if I see, QU is equal to 1.3 CNC plus gamma D NQ plus 0.4 gamma B N gamma. This is the formula for what, sir? This is the formula for square footing. Similarly, if you talk about the rectangular footing, see students, when I talk about rectangular footing, Q is equal to 1 plus 0.3 into B by L into CNC plus gamma D NQ plus 0.5 gamma B N gamma into 1 minus 0.2 B by L. Now see students, I will tell you simple logic. Why we have written the formulas like this? Because 0.3, 0.4, 0.5. That is the reason I have written in this order. You can remember circular, square and rectangular footing. If strip footing, they will give you CNC plus gamma D NQ plus 0.5 gamma B N gamma. Okay. So see students, these formulas you should be very much careful. For circular footing, it is 0.3 gamma B N gamma. For square footing, it is 0.4 gamma B N gamma. Sir, rectangular footing, this is the formula. So whether you have remembered the formula correct or wrong, if you substitute L is equal to B, it should come square footing formula value. So 0.5 into 0.8, 0.4. So our formula is correct. But you have to remember these three formulas if you are solving the problems related to shallow foundation. And here see students, here for phi is equal to 0, NC is equal to 5.7, NQ is equal to 1 and N gamma is equal to 0. And remember see students, we have net ultimate bearing capacity is equal to ultimate bearing capacity minus overburden pressure, which is gamma D. And net safe bearing capacity, QNS, can be written as net ultimate bearing capacity. Sir, first I have given you the formula for QU. If you have to calculate QNU, QU minus gamma D. So QNU can be written as QNU upon factor of safety. If they ask you gross safe bearing capacity can be written as QNS plus gamma D. And see students, we have to, in foundation, what is the main agenda? Sir, if you are as a structural engineer or a geotechnical engineer, everyone intention is in the point of RCC, the foundation is designed for shear failure. Sir, actually you can ask me the question, sir, why the foundation has been designed for shear in case of RCC? Because my dear students, the depth of the foundation the depth of the foundation in RCC point of view depends upon the shear. So that is the reason we take shear as the criteria in RCC, and in soil, settlement is the criteria. So soil should not fail in shear or soil should not fail in plate load test, and it is obtained practically. So what is net safe settlement pressure means? It is the net pressure that can be applied without excessive settlement is net safe settlement. But see students, let me tell you one important thing. In the design of foundation, what sir? In the design of see students, in the design of foundation, we are using the concept called net allowable bearing pressure. What is net allowable bearing pressure means? It is the net pressure that can be applied without excessive settlement or without excessive shear failure. Without shear failure or without excessive settlement. Let me repeat this one. It is the net pressure that can be applied without excessive settlement or without shear failure. So it is not a new term. It will be calculated minimum of QNS and QNP. The minimum value of QNS and QNP will be equal to QNA. So these terms are very important when you are designing a shallow foundation. Now let me tell you Now let me tell you the effect of water table. Sir, I have done a separate video on this in the playlist, but I will give you some insight now. But I have done one session on this only thing, sir. What is the effect of water table on, okay. Now see students, when I talk about the effect of water table on shallow foundation, okay, if I consider this as the depth of the foundation, if I consider this as width of the foundation, okay. See students, always remember that whenever there is a water table, okay, then definitely there will be a reduction in the bearing capacity. That funda is basic, okay. Water table is a disturbance you can feel. So here if there is a water table here, there can be two factors which we call reduction factors. What, sir? Which we call it as reduction factors. I'll tell you. For now, reduction factor is given as 0.5 plus ZW1 upon D, and reduction factor RW2 can be taken as 0.5 into 1 plus ZW2 upon B. So these are the reduction factors for RW1 and RW2. Now see students, how do we write RW1 here? Suppose see students, if I consider this as a foundation, okay, if I consider here, this will be ZW1. ZW1 is the distance from the ground level, okay, and if I consider this as depth D. Now what will be ZW2 means? ZW2 will be from the base, and if here I will take it as B. So actually you can ask me, sir, why you have used 0.5, why not other values? Sir, there is an approximation saying that gamma dash will be usually practically half of the gamma set. That is the reason I have applied 0.5. It is an approximation. Now see students, if the case 1, if the water table is at top, if I write here case 1, water table at the top or at ground level, you can write water table at ground level. When the water table is at ground level, the ultimate bearing capacity, if I take strip footing like this, CNC plus gamma dash NQ plus 0.5 gamma dash B N gamma. So what happens, I will tell you students, gamma, wherever you find gamma, gamma will be replaced by gamma dash. Or other method what you can do is, in this case, sir, other method you can do is QU is equal to CNC plus gamma D and Q. Sir, what you are doing, gamma you are replacing with gamma dash, right? So, or gamma sat is replaced by gamma dash, yes or no? So, because it is a saturated condition, you can write gamma sat is replaced by gamma dash. Here what I would like to tell you here is, here you are applying a correction to gamma and you are multiplying with a reduction factor RW1 plus 0.5 gamma B N gamma into RW. So here my dear students, the sincere advice for you is, you have to apply the reduction factors. One is RW1 and RW2. So RW1 and RW2 are the reduction factors which are applied. Either you can formula this method or either you follow this method. Okay, don't combine the two methods, sir. It's my sincere request. This method is somewhat easy. Okay, but this is also easy if you understand in a different way. Now see students, if the water table is at base, suppose see students, second case is, here the water table is somewhere here. Case 2, what I can tell you here is, in the case 2, if the water table is at and remember, see students, in the top, in the first case, If they ask you what is RW1 and RW2 means, RW1 and RW2 both will be equal to 0.5. Okay. In the case to C students, here depth is not affected. What sir? Water table is here. So this depth won't be affecting. So in this case, if we consider the reduction factors, RW1 will be equal to 1. Why? Because the depth of the footing is not affected. If the base is affected, RW2 will be equal to 0.5. Okay. Now see students, if this is very important sir. If the water table is at a depth greater than width. Okay, if the water table is at depth greater than width. Sir, if you are constructing a building, there will be some water beneath the surface, but it will be at some depth around 4 meter or 3, like very huge depth. The water will be at huge depth, suppose. So will that water will affect your foundation? No. So remember, this is a key point, sir. No effect of water table. No effect of water table. No effect of water table when the water table is at a depth. When the water table is at a depth. And the water table is at a depth greater than width. And another important word is there, sir. When the water table is at a depth greater than width, below the footing. This is also important. Below footing. So, see students, actually, this is one case. There can be water table at somewhere here, or in some cases, there can be at intermediate positions. Then you have to use this formula somehow. If the water table is intermediate positions, I told you already, no, RW1 is 0.15 into 1 plus ZW1 by B. ZW1 is the distance from ground level, and here what is ZW2 is? ZW2 is the distance from the base by depth. Sorry, here it is D, sir. 1 plus ZW1 by D, depth of the foundation, and here it is ZW2 upon B. Okay, so these are the important formulas. Okay. Next, read this question, students. I'll be back in a minute. Okay, just read the question. Students, have you read the question? Now see students, I have a beautiful question for you. The question here is the percentage reduction in the bearing capacity of a strip footing on a sand under flooding condition. That means water level is at the base of the footing. And when compared to the water level at a depth greater than width. So he is asking what, sir? The percentage change. Okay, what he is asked, the percentage reduction in the bearing capacity. Okay, now see students. First case is what, sir? When the water table is at base. Now he has told the footing is resting on sand. Sir, this has a huge meaning. Okay. First of all, what you should understand is, if it is a sand or a gravel, it is a cohesionless soils. What, sir? If it is a sand or a cohesionless soil, sorry, sand is a cohesionless soil or a gravel, it is a cohesionless soil. So you should know that C is equal to 0. Am I correct? If it is a sand, then it is a cohesionless soil. There the value of C will be equal to 0. The next important point I would like to tell you here is, after knowing the sand, it is a cohesionless soil and you know that it is C is equal to 0. Okay, now footing is resting on soil. Sir, this is a very important point. Whenever footing is resting on soil, you can say that their depth is equal to 0. Sir, these 2 points can be the key takeaways. When a footing is resting on the soil, D will be 0 and the footing for sand, cohesionless soils, C will be equal to 0. Now here, ultimate bearing capacity for strip footing is given as what, sir? CNC plus gamma D NQ plus gamma D NQ plus 0.5 gamma B N gamma. So this is the ultimate bearing capacity for strip footing. Here see students, when the water table is at base. Sir, when water table is at base, I told you only the third term. Here only the width term will be replaced. Anyhow, this will be 0, sir. So QU will be equal to 0.5 gamma dash B N gamma. Yes or no, students? Okay, when the water table is at base, only the third term will be replaced, gamma by gamma dash B N gamma. Why I have not written C and D? Because C is 0, this term is 0, depth is 0, so that term. Now, when the water table is at a depth greater than width, below footing, that means what you told? In this case, I told you clearly, see students, when the water table is at a depth greater than width below the footing, there will be no effect of water, so no effect of water table. So in this case, QU, no effect means there will be no reduction in the bearing capacity. In this case, QB is equal to 0.5 gamma B N gamma. Okay. Now, they are asking what they have asked, sir. The reduction in bearing capacity in percentage. Reduction in bearing capacity is equal to you can say that, sir, initially it is how much? When the water 0.5 gamma B N gamma, or you can write it is saturated condition, gamma sat gamma B N gamma minus 0.5 gamma dash B N gamma divided by 0.5 gamma sat B N gamma. Okay, so into 100. And remember I told you approximately we can write gamma dash is equal to half into gamma set. Sir, if you apply the reduction factors also, you will get easily. So gamma dash is equal to half into gamma set. So this value can be written as 0.5 into minus 0.5 into, sir, gamma dash I will write it as 0.5 into gamma dash. So if I take here gamma sat B, n gamma common, and here also I'll write 0.5 gamma sat B, n gamma. So see students, gamma sat B n gamma, gamma sat B n gamma cancel, into 100 you will have. So this value will be equal to 1 by 2 into 100. So this will be equal to 50% reduction. So this value will be equal to how much, sir? 50% reduction. Students, are you following? So what is the reduction in bearing capacity is nothing but how much? It is nothing but 50% reduction. Clear, students? Very good. Now the next question we have is the width of a square footing and the diameter of a circular footing are equal if both the footings are placed on the surface of a sandy soil. The ratio of ultimate bearing capacity of a circular footing to that of a square footing. They are asking what, sir? The ultimate bearing capacity. They are asking here, see what they are asking, the ratio of ultimate bearing capacity of circular footing to the ratio of ultimate bearing capacity of square footing. This is the one they are asking. Okay, so what is this value? Now again see students, I told you in the problem they have given it as a sandy soil. So for sandy soil, what will be the value of C? For sandy soil, the value of C will be equal to how much, friends? It will be equal to C will be equal to 0. And remember here, the footing is resting on a soil. The next one what I told you, sir, the footing is resting on soil. When the footing is resting on the soil, D will be equal to 0. When the footing is resting on soil, sir, D will be equal to 0, and for sandy soil, C will be equal to 0. Am I clear, students? So as C is equal to 0 for sandy soils and for footing resting on soil, D will be 0. So for circular footing, in this case, actually Q is equal to, for circular footing, if you remember, I'll write the entire formula. It will be equal to 1.3 CNC plus gamma D NQ plus 0.3 gamma B N gamma. And for square footing, Q is equal to 1.3 CNC plus gamma D N Q plus 0.4 gamma B N gamma. But see students, are you following everyone? See students, if you are saying here you should understand that here for cohesionless soil C will be 0 and D will be 0. So here what you can write here is, because you can plug in these two values, here you can write 0.3 gamma B N gamma upon 0.4 gamma B N gamma. Remaining two terms will be 0. That is the reason I have written like this, sir. So gamma B N gamma cancel, 0.3 by 0.4 can be written as 3 by 4. So the answer here is how much, sir? So the answer here is 3 by 4. So in this problem also the key TKYs are, for sandy soil C will be 0, footing resting on soil D will be equal to 0. And you have to remember that the ratio of you have to remember the ultimate bearing capacity formulas for circular as well as for the square footing. Okay. Next question, please go through this question, students. See students, just read the question there. you read the question, students? Now, very good, students. Now, let me tell you, sir, here I want to tell you before solving this problem, let me go through the concepts of pile foundation, a basic overview. Sir, see, when I talk about pile foundation, okay, pile foundation comes under, sir, what is the necessity to have a pile foundation? Sir, already we have a shallow foundation. So, then what is the purpose to have pile foundation? Sir, see, when the subsoil is very weak, okay, when the soil is very loose, subsoil is very weak, in that case we go with pile foundation. Okay, when the loads are very heavy, subsoil is very weak and loose, in that case we go with the pile foundation. Okay, students. So piles will be classified into different types. Actually, the piles will be classified based on the load transfer. So based on the load transfer, we have one pile called combined end bearing and friction piles. We have a concept called combined end bearing and friction piles. Combined end bearing and friction piles. When I talk about combined end bearing and friction piles, here see students, here ultimate bearing capacity can be taken as it is end bearing resistance plus skin friction resistance. See here, if you consider this as a pile, students, okay, if a load is acting on the pile, here there will be a, in this case, here you will have a resistance due to friction and you will have end bearing. Sir, actually they will study separately also, but practically it is impossible. And remember students, in the design of pile foundations, we take that load is transferred by both end bearing and friction and we apply this equation. Here QB can be written as FB into AB and QS can be written as FS into AS. Okay, here what do you mean by FB is the end bearing resistance and FS is the skin friction resistance. What is AB means? Area at the base and AS is the surface area. Okay, now see students, as I told you, QU is equal to what, sir? QU is equal to FB into AB plus FS into AS. So this is the main. Sir, see, piles which are provided at an inclination is known as what? Batten piles. Okay, so that is another important previous gate question, sir. Now see students, how do you design piles in? How do you design piles in? Sorry, clays. Okay. Here see, when I design piles in clays also the formula will be same, but the FB and FS values will change. In case of clays, FB value will be equal to C into NC. And one more important thing, see students, there will be a chances that they will give you unconfined compressive strength. What is QU? QU is nothing but the unconfined compressive strength. If they give you QU is what, sir? Unconfined compressive strength. When QU is given as unconfined compressive strength, here C can be written as QU by 2. So unconfined compressive strength is calculated, C is equal to half of QU. So here piles in clays, FB is equal to CNC, and you can write FS is equal to alpha into C. See students, if they have not given the value of NC value should be taken as 9. And here alpha depends upon the consolidation. If they have not given, they have to, here also you have to take 1. So alpha can be taken as 1 if they have not mentioned anything. So what is alpha here is, alpha is known as the adhesion factor. What is alpha, see students? Alpha is nothing but the adhesion factor. And see students, if I take for example, if it is a circular pile, so circular pile area at base, if you consider this as a pile, okay, the area at the base is nothing but this area. So area at base will be equal to pi by 4 d square. If they ask you what is the surface area will be equal to pi into d into L. So this is the surface area and this is the base area. So see students, what is base area, sir? Base area is equal to pi by 4 d square and surface area is equal to pi dl. Okay. So this is the formula for pile in clays. Next one we have is pile in sands. Now see students, when I talk pile in sands, here ultimate bearing capacity QU can be written as what, sir? FB into AB plus Fs into AS. Now see students, what do you mean by FB here? FB is nothing but what, sir? And the bearing resistance. So FB can be taken as, can anyone tell me what is the formula for FB? FB is written as sigma V into NQ. And here see students, where NQ is the Terzaghi bearing capacity factor due to surcharge. Here sigma V can be taken as gamma into L if L is length DC. What is L? L is nothing but the length of the pile. So or you can write here. Here this is nothing but, if I consider this as a pile, here this is called the length of the pile. Now if gamma into DC, when DC is less than or equal to L. Okay. So similarly, immediately anyone can ask me what is DC. Sir, DC means it is the depth up to which. So this depth can be taken as DC or critical depth. It is the depth up to which vertical stress varies linearly and after the depth it remains constant. So what is DC? DC is nothing but the critical depth up to which the stress varies linearly and after that depth it remains constant. Similarly, what is Fs, sir? Fs is nothing but K into sigma average into tan delta. Okay, delta is the angle of friction between the wall and the soil. Sigma average is nothing but the average effective stress. See students, suppose if you have calculated effective stress like this, for suppose, what will be the effective stress here means 0 plus sigma 1 by 2. What is the effective stress here means 0 plus sigma 1 plus sigma 2 by 3. What will be the effective stress means if they have given 0, 1, 2, 3 like that. Okay. So you have to take the average effective stress in that case. Okay. So we have discussed the pile in sands and also the pile in clays. Similarly, see students, we have a concept called efficiency of the pile group. Efficiency of pile. Sir, see, what do you mean by efficiency of pile group is, sir, it is the ratio of average load on the pile to the ultimate load of single isolated pile at which the failure occurs. What, sir? Again I am repeating, the efficiency of pile group is defined as it is the average load on the group of the pile to the ultimate load of single isolated pile at which the failure occurs. So here see, efficiency can be written as average. If I take group capacity as Qg, sir, if I take Qg as the group capacity, the average load can be taken as what, sir? Qg by N. This is the average load on the upon QUI into 100. So the formula for efficiency of pile group can be written as N into QUI into 100. Sir, the efficiency of pile group depends upon spacing between the piles also, and sometimes the efficiency of pile group can be more than 100. Let me tell you, sir, the most important concept in piles, that is group capacity of piles. Okay. Sir, see, what I would like to tell you in a mathematical relation, let me explain. Sir, if I have taken a pile group like this, okay, if I take pile group capacity of 1 is x1, if I take the pile group capacity of 2 is x2, and if I take the pile group capacity of 3 is x3. So what will be the group capacity means x is equal to x1 plus x2 plus x3. This is how you will think. But the pile group capacity need not be equal to the sum of the individual capacities of the pile. What, sir? The pile group capacity need not be equal to the sum of the capacities of individual pile because of the stress overlap. Because of the stress overlap, the pile group capacity need not, because of this is the stress overlap region, right? Because of the stress overlap region, it need not be equal to the sum of the individual capacities. So that is called the group capacity of the piles. In group capacity of piles, we have two things, students. One is the individual failure. In group capacities, we have one is the individual failure, and other one we have is the block failure. Okay. We have two types of failures. We assume as a group they will fail individually. Okay, now let me discuss the formulas here. Now see, students, in group for individual failure, QG is equal to what, sir? N into QUI. Okay, now see, students, here QG can be taken as what, sir? QG can be written as N into FB into AB plus Fs into AS. So see, students, this is the formula for group capacity of pile, okay, for individual failure condition. If you consider as a block, okay, sir, for a block failure, what I will do is, I will tell you how to calculate the areas and all. Sir, see, if you consider there is a block of like 12 piles which are arranged in 3 rows. Okay, I am just giving an example. Sir, why it is 12? Why can't it be 16? It can be anything. I am just taking this pattern and I am just calculating the values. So here, what is this, sir? This is called L0 and this is called B0, if I assume. Okay, here if I take individual spacing as S, so this is also S, so this is also S. So see, students, from this we will have half pile here and all. So L0 will be equal to 3S plus D, where D is the die of pile, And what is S, sir? What is S here? S is nothing but the spacing. So again I am writing, sir, L0 can be written as 3S plus D. Similarly, B0 can be taken as 2S plus D. Okay. Now see, students, here what I would like to tell you here is the most important thing, area of the block. If you take area of the block means L0 into B0. You will take the entire block, entire 12 piles, whatever there, you take it as a single pile only. That is the reason we are taking area of block. And if you talk about the surface area of the block, it will be equal to 2 into L0 plus B0. So this is the area of the block, L0 into B0. Surface area of the block is 2 into L0 plus B0. Now see, students, how do you calculate ultimate bearing capacity? Here is just plug in these values, FB into capital AB plus Fs into capital AS. Sir, see, in individual failures, I have multiplied with N means number of piles. Here I am not multiplying with N because I have taken the entire pile as 1. So this is what is important about the group capacity of pile. Now see, read this question, students. Good, sir. Now let me tell you the problem. Here a pile is driven in a uniform clay of large depth. The clay has an unconfined compressive strength of 90 kilonewton per meter square. The pile is 30 centimeter in dia and 6 meter long. Determine the safe load carrying capacity of the pile. Assume factor of safety as 3 and assume addition factor as 0.7. Now see, students, let me tell you, here they have given unconfined compressive strength is how much, sir? They have given unconfined compressive strength as 90 kilonewton per meter square. The unconfined compressive strength is given as 90 kilonewton per meter square. And the pile dia is given as, the pile dia is given as 30 centimeter, or you can write it as 0.3 meter. Okay. And they have given length of the pile is equal to, length of pile is equal to 6 meter. Okay. What is the other thing they have given, sir? Safe factor of safety is 3. Factor of safety is 3 and alpha is equal to 0.7. Now see, students, let me calculate. They have asked safe bearing capacity, sir. Let me calculate the ultimate bearing capacity. Sir, this is QU means here unconfined compressive strength, or you can write Q because you will confuse again. Here ultimate bearing capacity QU is given as formula what, sir? FB into AB plus FS into AS. Now see, students, first we will calculate FB. What is FB, sir? C into MC. What is C value here? Unconfined compressive strength is 90. So C value will be equal to how much, sir? 90 by 2. That will be equal to 45 kilonewton per meter square. What is the C value, sir? C value will be equal to 45 kilonewton per meter square. So here C value will be equal to 45. And what is the NC value, sir? NC value is equal to 9. So this is what you will be calculating in FB. Now see, students, let me calculate. What do you mean by FS? FS is equal to alpha into C, where alpha is equal to how much, sir? Alpha is given as 0.7. 0.7 into C is how much, sir? 45. Now see, students, just plug in these values. Ultimate load is equal to FB 45 into 9 into area of the base. Area at the base is pi by 4 into 0.3 square plus what is FS? 0.7 into 45 into pi dl. So pi into 0.3 into 6. So what is this value, sir? What is this value? But they have not asked safe load, sir. They have asked what is the determine the safe load bearing capacity. They have not asked the ultimate load. First, let us calculate what is the ultimate load. Everyone, can anyone describe? Can anyone tell me what is the answer, sir? Anyone? Are you following, students? How much you got? What is the ultimate bearing capacity you have calculated, sir? Sir, 45 into 9 somewhere 360, 405. So if you calculate this, you will get roughly around around 207 kilonewton per meter square. I am just rounding off, sir. It will be around 207 kilonewton per meter square. Very good. Now see students, what will be the safe load, sir? The safe load is nothing but ultimate load upon factor of safety. What is safe load? Safe load, sir, see, when you talk about shallow foundation, in shallow foundation you will come across the things like net ultimate bearing capacity, net allowable bearing capacity, net settlement pressure. Here only two terms, one is the ultimate bearing capacity and the next one is the net ultimate bearing. So QS can be written as safe loading bearing capacity is 207 divided by 3. You will get roughly around 69 kilonewton per meter square. So see students, what are the key points from this? Very good, Swetanshu. That is the reason I have rounded to 207. You have written 206.75. That is absolutely correct. But I have rounded to 207. Okay. Now see, what are the key points in this is, you should remember the ultimate bearing capacity of a pile is taken as both by end bearing and the friction, FB into FS plus, sorry, FB into AB plus FS into AS. As it is a clays, FB value will be equal to C into NC. Sir, why I have taken NC 9? If the question they have not given you NC, you have to adopt the value of 9. And alpha is nothing but the addition factor and C is cohesion. And remember again and again, the cohesion is half of the unconfined compressive strength. Okay, we'll move on to the next question. Please read this question, students. Just, I'll give you a minute. Just read, go through that question. Okay, let me go through this question, students. First, we have a square group of 9 piles was driven in a soft clay of large depth. Length of the, dia is 30, length is 10 meter. Okay, dia is how much, sir? Dia is 30, length is 10 meter. If the unconfined compressive strength is 18 ton per meter square and spacing is 90 centimeter per center to center, what is the capacity of the, and what is the capacity of the pile group? Factor of safety is 2.5 and adhesion factor is 0.75. Now, sir, see, it is a square group. So what are they have given is, are you following, students? Okay, very good. It is a square group. It is a square group. And here how many piles are there? There are 9 piles. Okay, see students, next. Here length of the pile is 10 meter. Dia of the pile is how much, sir? Dia of the pile is 0.3 meter, which is equal to, they have given as 30 centimeter. I have converted into meter, that is 0.3 meter. Adhesion factor alpha is equal to 0.75 and they have given Q, unconfined compressive strength is 8 ton per meter square. Sir, I just told you now, unconfined compressive strength is given, then what will be the cohesion? Cohesion will be equal to 8 by 2, or you can write it as half of the unconfined compression, that is 4 ton per meter square. And the spacing is given as how much, sir? Spacing is given as, spacing is given as 90 centimeter. What is the value of spacing, students? Spacing value is given as 90 centimeter. So here you can take spacing value as how much, sir? You can take spacing value as 0.9 meter. Spacing value can be taken as how much? 0.9 meter. Now see, students. So they have given you a square group, right? They have given you a square group. Okay, whenever they have given you a square group, students, here what I would like to tell you here is, here they have given square group. So 3 columns in each row and 3 columns, 3 piles in each row, and I have arranged like this. So what will be the L naught, sir? L naught will be equal to spacing 1, spacing so 2s plus d. So you can write it as 2 into 0.9 plus 0.3. So L naught will be equal to how much, students? It will be equal to 2.1 meter. Okay. So first of all, in area of block, if I consider area of the block, if I take, this will be equal to 2.1 into 2.1. And what will be the surface AS of block? It will be equal to pi into 4s, 4 into 2.1 into length of the block is 10 meter. Are you getting me, sir? Surface area of a square is 4s into length of the pile. Okay. Now let us do individually. If we solve individual failure, see students, individual failure, I told you what is the group capacity. Group capacity is equal to N into QUI, which is equal to N into FB into AB plus FS into AS. So see students, if they have given you these values, here what is N, sir? 9. N is given as 9. FB is how much, sir? CNC. 4 into NC value will be 9. Area of the block will be, area of the pile, individual pile. So pi by 4 into 0.3 whole square. What is 0.3, sir? 0.3 is nothing but the dia of the pile. So Fs is equal to what? Alpha into C. So what is the alpha value they have given? 0.75 or 0.7, sir? Alpha is given as 0.75. Sir, let me check the factor of safety also. 2.5. 0.75 into C is 4 into pi dl. Pi into 0.3 into L. L is 10 meter. So if you solve this, what is the answer you will be getting, sir? What is the answer you are getting? See students, if you calculate here, QG, group capacity, will be taken as 277.37. But actually, see students, you have to get the safe capacity. Safe capacity means QGI, QG individually by factor of safety. Factor of safety is how much, sir? It is 2.5. So you can write here 277.37. Sir, what are the values? It is ton summa. Sir, if they have given you FB into, this is group capacity is in tons. It is not pressure, divided by 2.5. So it will be equal to how much, sir? 250 is 100, 25, 110, 275, 277.5. It will be how much, sir? 110.9 or something. Check it, sir. How much value you got? What is the value you got, Amma? 110.95, right? Am I correct or wrong? You will get 110.95. Sir, this is the value which you have calculated individual failure. But we have to calculate for group failure also. Sorry, not group failure. You should calculate block failure. Sir, we have to calculate block failure. Sir, what is the block failure? QG is equal to what, sir? FB into capital AB, area of the block, plus Fs into AS. Now see students, what is FB? NC, CNC. So 4 into 9. Area of the block is how much, sir? 2.1 into 2.1 plus Fs is how much? Alpha into C. 0.75 into 4 into AS is how much, sir? 4 into 2.1 into 10. How much you got the answer, sir? How much you got? Very good, Swetanshu. What is this value you got? If you solve this, you will get a value of 490.74. Okay, tons. So students, usually I don't calculate safe load also because it is already higher. So if you talk about the group capacity, the key point I would like to tell you is you have to take the minimum value of, sir, you have to take the minimum value of individual failure and block failure. So block you got higher value. So I am not taking block. Individually I got 110.95 tons. So the answer here is minimum means the answer you will get is 110.95 tons. Okay. Sir, the key points in this problem is whenever you are calculating the group capacity, there can be two failures. One is the individual criteria, other one is the block criteria. You always take the minimum of those two as the load, okay, as the group capacity, and you have formulas, surface area, base area, and how to calculate the area of the block, area of the surface and all. And always remember, cohesion will be taken as the half of the unconfined compressive strength. Now let us go into the most important concept in the pile foundation, that is negative skin friction. What, sir? Negative skin friction. Sir, let me tell you, what do you mean by negative skin friction means? If I consider here, this is a pile, okay, usually in the loosely deposited soils, okay, see students, this is the length of the pile if I take, okay, if I take this as the length of the pile, and if I consider this as loose deposited soil, LC, and this is dense soil. Now let me tell you, see students, what do you mean by negative skin friction? When the surrounding soils, sir, see, when the surrounding soil of the pile settles more than the pile, a downward drag is observed. What, sir? When the surrounding soil settles more than the pile, a downward drag is observed. Okay, due to that downward drag, the net load carrying capacity of the pile is reduced. Again, I am repeating the students, when the surrounding pile settles more than the pile, when the surrounding pile settles more than the pile, a downward drag is observed. Due to this downward drag, the net load carrying capacity of the pile is reduced. And remember, see students, this is observed in loosely deposited soils and it is occurring due to friction only. So whenever you take negative skin friction, see students, you have to take Fs into As. You need not to take the values of end bearing. Consider only the Fs into As. And another important and the most important thing, students, the negative skin friction when you are calculating, whenever you are calculating the individual and block failure, you have to calculate the maximum. You have to take the maximum value, and in the safe loading carrying capacity, you have to reduce this. Again, I am telling you, when the surrounding soil settles more than the pile, a downward drag is observed. Due to this, the net load carrying capacity of the pile is reduced. And this phenomenon is called negative skin friction. This is observed in loosely deposited soils or recently filled up materials. Here we will take only the value, the capacity or the load which is coming due to friction. But when you talk about as a group, you will calculate individually and block, but you will take maximum because it is a reducing factor. In the group capacity, we have taken the minimum, but here we will take the maximum. Very good, Swetanshu, very good. Now let us see. Sir, see, I hope you are clear with next important point is to obtain a undisturbed sample, to obtain an undisturbed sample, we have something like area ratio. Sir, see, we have samplers like this, right? This is a core cutting edge kind of thing. Now see students, if you consider here, let me tell you in another way students, 1 second. Sir, see, if I talk about the area ratio and we have inside clearance and also outside clearance. Okay. Now see students, here area ratio is given by the formula d2 square upon d1 square by d1 square into 100. Inside clearance is d3 minus, okay, you can write here d1 minus d3 minus d1 into d1 into 100. Outside clearance is d2 minus d4 by d4 into 100. Now see students, actually these comes under soil exploration. What do you mean by soil exploration? Means the depth of the soil, how much soil you want to excavate, that depends upon a significant depth. So here we talk about disturbed soil and undisturbed soil. When the water content and the soil remain intact, then it is called undisturbed soil. If the water content and the soil structure are disturbed, then it is disturbed soil sample. So here to obtain undisturbed sample, area ratio should be less than 10%. Inside clearance should be 0.5 to 3 percentile. There are some limitations. Okay, how much sir? 0.5 to 3%. And outside clearance should be 0 to 2 percentile. So these are the values how you can obtain a undisturbed sample. Okay, please go through this students. See students, here I just showed you, know, what do you mean by D1, D2 and all, you should know, right? So this is D2, it is a line diagram sir. This is D3 and this is D1. This is D4. Okay, so these are the means factors how you can obtain a undisturbed sample. Next, we have the most important last point, SPT. What is SPT, sir? Standard penetration test. Sir, some don't think it is standard Proctor test. In compaction, you'll standard penetration test means it is the number of blows. It is the number of blows required for 30 centimeter penetration. What sir? First of all, you should remember, see students, what is SPT means? It is the number of blows required for 30 centimeter penetration. So don't think that it is a value. It is just a value how many blows are required for 30 centimeters penetration. Here see students, SPT, sir see, if it is a dense soil, number of blows will be more. Right or wrong students? Number of blows will be more, because to compact that soil you require more number of blows. So indirectly when you do the SPT test, you will get an idea about the shear, the cohesion and phi values. Thereby you can at least estimate the shear strength. It is not the exact value, you can at least estimate. So see students, what is standard penetration test means? It is the number of blows required for 30 centimeter penetration. In case of dense soils, number of blows will be more. By that you will have an idea on the cohesion and the angle of internal friction. Based on that, you will get an idea about the shear strength. And when I talk about the SPT test, see students, in SPT we have first one we have is the overburden correction. Okay. Now see students, what do you mean by overburden correction? Suppose what you feel in overburden correction students, if it is a deep foundation, we will assume that the number of blows required are more. If it is a shallow foundation, then you feel that number of blows are required or less. But to have an uniformity, we apply the overburden correction. So here corrected N value is equal to 350 divided by sigma plus 70 into NR. Into what, sir? NR. What is NR? NR is nothing but the recorded N value. What is NR? See students, corrected N value is nothing but 350 plus sigma plus 70 into NR, where NR is the recorded N value. And remember, see students, in case of water table is present, your number of blows will not be correct. So remember, we have a correction called dilatancy correction. So this will be done here. Okay. When I talk about dilatancy correction, and remember, see students, dilatancy correction should be followed by overburden correction. You cannot do first the dilatancy correction. It should be done only after the overburden correction is done. So corrected value will be equal to recorded value. That means no dilatancy correction is required if the recorded value is less than or equal to 15. So dilatancy correction comes into picture when recorded value is greater than 15. So this value will be equal to 15 plus NR minus 15 upon 2. So this is the formula for corrected N value. Okay. So see students, so these are the two important corrections in standard penetration test. Now see students, here I have provided the Telegram link. So if you want to really go through the notes, sir, if you want, sir, in this foundation topic, I focused on the stability of the slopes, earth pressure topic, shallow foundation, deep foundation, and soil exploration. See students, if you want to the updates of the branches, like which subject you want to join the session, or if you want to go through the notes, any kind of information about the IMS Gate Academy related to the YouTube or related to the questions related posted, then definitely you can follow this Telegram group. And in this Telegram group, even the quiz mode, every day we will be publishing the quizzes and all. And we will have sometimes expert sessions on the important topics and all. Now let me tell you the other important thing. See students, what we provided IMS Gate Academy. See students, I am proudly saying that we at IMS Gate Academy are providing the offline gate coaching at Bangalore and offline gate coaching at Vijayawada. And we are providing the online gate coaching. The online gate coaching can be in a recorded format or a hybrid model or complete online model. So here whatever we provide, that will be around 800 plus for hours for civil engineering, and we understand the concepts, and we will deliver the concepts in a in a proper timetable manner. And the second important thing is material. Whenever I say you, perfect makes man perfect, my dear students. So practice makes man perfect, right? So how do you practice these things? So to practice, you should have an exercise book, you should have a chapter book, and you have to have some test series. So my dear students, for every subject, we are providing the subject test. In addition to that, we have exercise book where we have given level 1, level 2, level 3 questions. And these questions will be very helpful when you are preparing for the GATE exam. Apart from this exercise book, we are providing the GATE questions with 30 years previous year solved questions. And also we have why IMS is proven track record in this 45 years of industry is it has a beautiful means students has the beautiful opportunity to interact with the faculty directly. Okay. Offline, sir, Srujana, we don't have offline gate coaching at Hyderabad, Amma. Srujana, you can, we have offline gate coaching at Bangalore. So, in the description, we have the Bangalore, like Rahman sir will be the counseling person. You can contact counseling person. I will be, okay, I will share your number, okay. I will share his number if you want any queries related to that. And apart from this, see students, we have a one-to-one mentoring session. This is a beautiful program where the student Suppose if you are from a diploma background, I'm not generalizing, this is the common things we have observed. The people will feel difficulty in solving maths and aptitude. But if you are from an engineer, MSET, or from a technical exam background, sorry, from the like +2, then they will feel very difficult in core topics. So there is a difference. In this way, people try to interact one to one and they want to solve their like doubts or any roadmap for the entire gate. And we have also have the doubt solving portal. Actually, what do you mean by doubt solving portal is, in the doubt solving portal, people can post the doubts and that doubts will be clarified within 24 hours of time. So we have two beautiful features where the student success has been achieved. Okay. Swetanshu, I'll definitely do that, Swetanshu, I'll share it. And we have the most important thing is 130 plus online test series. Like we have multiple subject tests, chapter tests, we have all India mock test, students. Students, if you are really writing for the gate and if you want to test yourself, then we have a beautiful thing, that is all India mock test, which will be a replica or it will be the same scenario how you will be writing in the gate exam. We will be having 12 all India mock tests, each of duration 3 hours. Apart from this, if you want to test yourself in a chapter, or if you want to test yours in a subject wise, or if you want to select some multiple subjects, like if you, there will be a question which is related to SOM and structural analysis, there will be a question formed and how do you solve this. So all these test series will help you a lot. Okay, students, and thank you once again. I hope this session will help you the entire concepts of the foundation. If you are really interested in this session, you can contact, you can join in the Telegram group, and please like and share this session. Thank you. Bye bye.